Welcome to the Wonderful Seagulls podcast, where we explore the loud, clever, chaotic world of gulls. Before we dive into today's gull story, please like this video and subscribe to the channel so you don't miss more urban wildlife, gull behavior, and neighborhood drama. Today, we're unlocking some truly mind-bending secrets about a behavior you might not even realize these birds do, and that is migration.
So, do all gulls migrate? I know exactly what you're thinking. When you picture a gull, you're probably picturing that classic parking lot fry stealer, just hanging out at the local beach or the fast food joint all year round. But the Loridae family, that's the scientific name for gulls, is incredibly diverse, and it completely challenges that stereotype. We're literally talking about a globally distributed lineage of seabirds that breeds on every single continent, all the way from the high Arctic down to the edges of Antarctica. And as we're going to see, their travel itineraries are just as varied as their habitats.
Okay, let's dive into our roadmap for today. We're exploring the spectrum of flight, ecological drivers, social dynamics, the family divide, energetics and survival, and finally, the genetics of migration.
Starting off with Section 1, the gull migration spectrum.
The absolutely most important thing to understand right out of the gate is that gull migration isn't just a one-size-fits-all behavior. It's a highly flexible continuum. For example, you have permanent residents like the European herring gull who basically just stay near their coastal breeding territory year-round. Then there are partial migrants like Ulrog's gull, where a cohort literally splits up. Some individuals migrate while others just stay put. Then we have short to medium travelers like the common gull, moving from inland areas out to ice-free coasts. And then at the extreme end, you have the long-distance champions, right? Like Sabine's gull, flying thousands of kilometers from the high Arctic all the way down to South America and southern Africa. It's wild.
Across all 54 recognized species of gulls, these varied travel strategies don't just happen randomly. They are heavily influenced by geography, the age of the bird, and some deeply specialized individual behaviors that we're going to get into today.
Moving into Section 2, ecological and anthropogenic drivers.
Now, what actually triggers these massive movements? Well, beyond plunging temperatures and shrinking daylight in the winter, it ultimately comes down to trophic resource availability, which is really just a fancy science way of saying food. But to pull off these crazy geographical shifts, they rely on an absolute biological superpower. It's called the supraorbital gland. It's this highly specialized gland right near their eyes that actively excretes salt from their blood. What that means is a migrating gull can seamlessly transition from breeding in a freshwater inland lake directly to a hypersaline ocean coast in the winter without skipping a beat. It's truly amazing.
But humans are kind of changing the game here. Human-made resources have heavily subsidized some gull species, fundamentally altering their evolutionary baseline. We're talking about open waste landfills packed with energy-dense food, agricultural tilling that churns up new resources, and marine fishery discards that create incredibly predictable food niches. Objectively speaking, this sheer abundance has actually truncated the migration distances for some species. It heavily favors much shorter journeys, or it's even turning historical migrants into local homebodies.
All right, Section 3, social dynamics of flight. Let's bust a major myth right now. Gulls do not all flock together in a massive V formation heading south. It's completely split. On one hand, you have solitary or small group migrants. These are opportunistic generalists like herring gulls who travel completely independently. They don't need a flock to help them find a scattered landfill or a fishing harbor. But on the other hand, you definitely have highly social flock migration, insect-eating or pelagic, meaning open ocean gulls, like Franklin's gulls, depart their dense colonies simultaneously. They lock into massive, perfectly synchronized V formations for incredible aerodynamic efficiency.
And to give you a real sense of scale for those highly social species, get ready for a jaw-dropping statistic. Once they reach their wintering grounds in South America, social Franklin's gulls can form massive, dense feeding flocks offshore of up to 500,000 birds. I mean, just imagine 500,000 gulls perfectly coordinated out over the ocean. No way, right?
Now, what's really fascinating is how all this impacts gull romance. Gulls are actually long-lived birds that form monogamous pair bonds, often lasting for decades. But when autumn hits, mated partners depart the breeding grounds entirely independently, and they often winter in completely different geographic regions. That's right, these long-term couples take separate winter vacations, sometimes thousands of kilometers apart. It might sound a little cold, but honestly, it's a brilliant adaptation. It allows each bird to prioritize its own body condition and food needs without having to worry about their partner.
But don't worry, romance isn't dead. Come springtime, they execute an absolutely flawless reunion. Despite spending the entire winter continents apart, the separated partners use shared endogenous rhythms, basically their internal biological clocks, and an exact memory of their territory to arrive back at the very same nesting site almost simultaneously. It is an absolute masterclass in long-distance coordination.
Section 4. The Family Divide.
So how exactly do gull families handle this epic autumn migration? Well, prepare for some tough love through a process scientists call differential migration. You see, gulls never migrate as family units. In fact, parents completely abandon their young before the journey even begins. In species like the common gull, subadults might depart in week 1. Then the breeding adults head out around week 3. And the poor first-year juveniles, they are left behind to figure it out for themselves, and they don't depart until around week 5.
The crucial takeaway here is that these young gulls are completely on their own. And honestly, it gets harder because of spatial segregation. The larger, dominant adult birds absolutely monopolize the best, highly productive wintering territories close to home. Because of this competitive exclusion, the younger, weaker gulls are physically forced to navigate globally, flying much farther south to marginal grounds just to avoid competing with the older, stronger birds.
And science shows exactly which babies get pushed out first. It all comes down to genomic integrity. Juveniles born into poor rearing conditions often have higher DNA damage or shorter telomeres, which are those protective caps at the ends of their DNA strands. These physically compromised babies lack competitive ability, forcing them to disperse from the colony prematurely. This, of course, leads to much longer, much riskier migrations. Essentially, a baby gull's physiological condition and genetics directly dictate when they leave the nest and exactly how far they are forced to go.
Which brings us to Section 5, Energetics and Adult Survival.
These intense, highly individual migratory decisions have profound literal life-or-death implications for the adult gulls, too. Generalist species like the lesser blackback gull use a truly brilliant energy-saving tactic called the fly and forage strategy. Instead of loading up on heavy fat reserves and flying the shortest direct route over open water, they follow coastlines. They stop frequently to forage and refuel continuously along the way. By traveling light with minimal fat stores, they drastically reduce the energetic cost of flight.
A gull's chosen wintering destination heavily impacts its chances of making it to the next year. For example, gulls wintering in pristine, low-impact zones like the eastern Arctic boast a really impressive 85% survival rate. The Great Lakes are right behind that at 84%. But then take a population wintering in the Bay of Fundy, which drops down to 73%. Wintering in heavily populated, industrialized coastal zones exposes these birds to intense management, airport hazing, and reduced fishery discards, taking a really noticeable toll in their overall survival.
And finally, Section 6, the genetics of migration. So we've seen that baby gulls migrate completely without their parents, right? So how on earth do they know where to go? Well, long-term research in Polish hybridization zones actually provides concrete proof. When a short-distance migrant, like a European herring gull, breeds with a long-distance migrant, like a Caspian gull, the resulting hybrid offspring inherit a migration distance and direction that falls exactly in between the two parents. It's a perfectly intermediate pattern.
Which leads us to this profound conclusion. Gulls possess an innate, genetically programmed migratory map. Unlike cranes or swans, birds that literally have to follow their parents for weeks to learn the cultural flyways, gull babies don't need anyone to show them the way. Their compass, their map, and their ultimate destination are written directly into their DNA.
So, knowing all about the epic, cross-continental journeys etched into their genetics, how will you look at your neighborhood gull tomorrow? The next time one eyes your French fries, remember, you might just be looking at a globe-trotting marathoner fueling up. Thanks for watching. If you enjoyed this episode, please like the video and subscribe for more gull stories, urban wildlife, and the ongoing adventures of gulls.